Welcome students, we'll begin with the topic of circuit diagrams. Now why do we need circuit diagrams? See, whenever you are studying about the electric connections, those are very comprehensive circuits. They involve various elements such as battery, cell, plug key, connecting wires, bulb, etc. Now in order to replicate that diagram in your notebooks or in your book, you need a symbol. Because it's not easy to draw a battery, it's not easy to draw a bulb. In order to simplify the representation of the circuit diagrams, we have symbols associated with each of the elements. So what is an electrical circuit? Electrical circuit, as we have studied, it is a closed connected circuits of various elements through which current flows. And what are the elements of the electric circuit? Electric circuit comprises different components such as cell, plug key, connecting wires. What is a cell? We've discussed that cell is used to generate potential difference across the circuit. And you know, it is very essential to have the potential difference across the circuit, because if the potential difference is not there, the current will not flow, right? Cause of the current flow is potential difference. So cell is an element that creates potential difference in the circuit, and there is a representation for the cell. We will study in the coming slides about that. Next is the plug key. Now what is a plug key? Whenever there is a circuit, we need to close the circuit, and we need in some cases we need to open the circuit, and in some cases we need to close the circuit. So plug key enables that. How does it enables that? In certain cases, if we close the plug key, the circuit becomes closed, right? We have a closed circuit and the current will flow. But if we open the plug key, the circuit is broken, the circuit is open, and in open circuit, current does not flow. So it stops the flow of the current. Okay, next we have connecting wires. It's pretty obvious why you need connecting wires, because you have different elements. Let's say you have cell, you have battery, you have plug key. Now you want to establish a connection between them. How can you do that? With the help of connecting wires. So various elements that you can see in front of you of the electrical circuit, various components, they have an associated symbol with it. So it's very important that you understand which symbol represents which component of the circuit, because the symbol will be appearing again and again, and it should be clear with you that what is the meaning of that particular symbol. Okay, let's start with the first. First is an electric cell. It is represented by two lines. Electric cell is represented by two parallel lines. These are the two parallel lines. The smaller line represents the negative terminal, longer line represents the positive terminal, right? So this is your symbol for the electric cell. Look at the shorter line, negative terminal, longer line, positive terminal. Your next component is battery. So battery or a combinations of cell. Now battery is a combination of different type of cells. You have multiple cells that are connected together, giving rise to the battery. Now look at the diagram. How is the representation? You have three cells which are connected. And how is the connection? Positive terminal is connected to the negative terminal. This is basically called the series connection. We'll study about the series connection in great detail in the coming session, but for the time being, you should understand that this particular representation, when you have positive lines, negative line, then again positive, negative, that combination gives rise to the battery, or is the representation of the battery. Even battery, you will show longer line, only one end you will show as positive and the other end as negative. Okay. The third component is plug key or switch. Now, what is a plug key or switch? As we have discussed, plug key enables us to close the circuit. It also enables us to open the circuit, right? So, this particular representation, when you have brackets without the dot, is the representation of open switch or open key. Okay. In this situation, current will not flow. Okay. In this situation, the current will not flow. Fourth is the close switch, or when the key is closed. So that representation, in that representation we have a bracket with a dot inside. That means now the circuit is closed, the current will easily flow. So this representation enables the closed circuit, so we call a closed switch. Next, you have a wire joint. Now, it's very important that you understand what is happening in the wire joint. In wire joint, two different wires are being connected together. They are soldered. They are joined together. As a result, there is a difference in the flow of the current. Let's say, in this scenario, let's say I is the current which enters, right? Now, if you have a joint, the current has two different directions to flow, right? Depending upon the connection. So, you will have I1, I2, right? So, what is happening at the joint? The current is dividing. That is the relevance of a wire joint, okay? Look at the sixth one. Wire crossing without joining. This is important. In this case, wires are crossing each other, but they are not joining, right? Let's say you have this wire, right? Let's say we have two group of wires. Let's assume that, okay? Now, this particular representation, let's say you have these two wires, yellow wire and a black wire. How will you do it? Wire without joining means this connection. Black wire is going over the yellow wire. This is wire without joining. But suppose if I open this yellow wire and I connect it and I join it with the soldering, right? Soldering is a process through which we join the wire. Then it is a wire joint, okay? But in this situation, when both are separated, they are just crossing over each other. It's a wire crossing without joining. Then seventh is your electric bulb. I think you're clear with what is an electric bulb. The symbol is this. See, most commonly we use this symbol because it is easier to draw. Next, we have a resistance, a resistor of resistance R. So, how is the resistance represented? It's represented by the zigzag lines that you see over here. Okay. Next, you have a variable resistance or rheostat. So, in the topic of Ohm's law, you will understand what is resistance, and then there we'll discuss in detail what is a rheostat and what is a variable resistance. But for the time being, just for the basic understanding, keep in mind that resistance, in case of resistance, the value is fixed, let's say R. But in case of the variable resistance or rheostat, this R value can change, okay? Now, how is the variable resistance shown? A zigzag line with this arrow on the top. That is the representation of variable resistance. Then a rheostat, you have this line going over the resistance. That is the representation of rheostat. Then we have ammeter. Now, what is an ammeter? It's a device that measures the current in the circuit. So, what is the representation? You have a circle with a A inside. Now, one thing should be kept in mind that whenever you have ammeter, you always have polarities, right? Like the battery or the cell had the polarity, one end was positive, other end was negative. But resistance did not had any polarity, right? That has to be kept in mind, because while you are making these circuits, these things should be clear how the connection has to be made. Now, look at the ammeter. You always have positive and negative terminals with it, okay? Ammeter, then you have voltmeter. Now, what does a voltmeter do? It measures the potential difference across the circuit. How is the voltmeter represented? It's represented by a circle with a V written over it, right? Capital V written over it. And keep in mind, voltmeter also have polarity. It has positive and negative terminal, okay?